Good morning. You're looking at a live view of Starship as it awaits its first ever integrated flight test from Starbase, Texas, in just a little over from 40 minutes from now. Today, we're hoping to see our Super Heavy booster and Starship spacecraft, collectively referred to as Starship, lift off together for the first time. Thanks for tuning in. I'm Kate Tice, Quality Systems Engineering Manager here at SpaceX headquarters in Hawthorne, California.
And I'm Shiva Bharadwaj, a space operations engineer here at SpaceX. Now, as many of you know, Starship is SpaceX's latest and largest vehicle developed to date. It represents a fully reusable transportation system designed to carry both crew and cargo to Earth orbit, the moon, Mars, and beyond.
If you've been following the development of Starship over the last couple of years, you know we've been doing a lot of testing leading up to this big one. Once fully developed, it will be the world's most powerful launch vehicle, with twice the thrust of Saturn V rocket and the ability to carry up to 150 metric tons to orbit. For reference, a 1-liter bottle of water is 1 kilogram, so 150 metric tons is basically 150,000 1-liter bottles of water, or, as I like to think of it, one rather lonely blue whale.
Now, today's test will be the first of many as we work towards transitioning Starship from a developmental to an operational program. Our primary objective today is to gather as much data as we can around the fully integrated vehicles. That means the booster and the Starship and the ground systems. While we have flown Starship in the past, this will be the first attempt of Super Heavy and the first opportunity to validate how the two vehicles operate together.
Any data that we get helps improve the future builds of Starship will be considered a success for the purposes of today's test. Every milestone beyond that is icing on the cake. The further we fly, the more data we can collect. If all goes well, today's flight test could last as long as 90 minutes from liftoff to an expected hard ocean landing for Starship. Whether we end the test with a hard landing or a rapid unscheduled disassembly, or some combination of both, excitement is pretty much guaranteed.
Now, if it does all go well, Super Heavy will fire up its 33 Raptor engines, and it'll lift off from the launch pad down in South Texas. About 3 minutes into the flight, we're going to hope to see the Super Heavy separate from the Starship spacecraft. It'll then perform a flip maneuver. So there's that. You can see that on your screen. And then it'll boost back in order to make a hard landing in the Gulf of Mexico.
And while that's happening, we hope to see Starship's 6-second stage engines ignite and watch as Starship coasts for about an hour at altitudes ranging between 150 and 250 kilometers before re-entering Earth's atmosphere and make its own hard landing in the Pacific Ocean about 250-ish kilometers offshore.
Now, we are getting great camera views right now, but that's because we are on the launch pad, so we've got umbilicals and connections straight to the vehicle. But we aren't expecting to get very many good views once we get past booster separation.
Yeah, we do promise, though, for any views that we do get, we will share them in real time. We are watching live with you all, so we're excited to see those views ourselves as well.
Now, in a little bit, we are going to take a closer look at the vehicle and the launch pad. But first, today is a super exciting day. Everyone on the teams across Starship have been preparing, doing a number of tests and dress rehearsals for today's launch attempt.
Yeah, that's exactly right. In fact, we saw a nice little recap of those tests in the intro video to today's webcast. For those of you that are following along, you know that many of those tests ended in those rapid unscheduled disassemblies, or RUDs, as we like to call them. And it's been a long road to today. Just in 2022 alone, we had 9 static fires. We've had a couple of wet dress rehearsals. And of course, the launch control team has done numerous simulations as well.
So major shout out to the teams that have been preparing for today's full up integrated test. In fact, we've got a shot of Star Command at the South Texas launch control team. Look at all the people ready for today's launch attempt.
Yeah, that right there is our South Texas Launch Control Center. That is basically ground zero for everything that is happening today, in addition to a couple other control rooms that we have operating as well with operators on console, including the Mission Control Center here behind us here in Hawthorne, California. But with that being said, our very own Zachary Lupin is one of our SpaceX employees at our watch event in South Padre Island. Hey, Zach, how are things going on the ground?
It is a great day for a test launch today, Kate. Hello, everyone. My name is Zachary Lupin, and I'm an avionics reliability engineer here at SpaceX, and I'm at the Cameron County Amphitheater, where a growing number of SpaceX employees are gathering to watch what we hope is the first liftoff of a fully integrated Starship. Now, the Starship team has worked incredibly hard for today's launch test. Over the past weekend, teams held a launch readiness review, which included a comprehensive review of all of our vehicle systems, looking at avionics, GNC, communications, software, structures, as well as our Raptor engines and propulsion in general. Now, we are only about 5 miles away from the launch pad, so it's a pretty good view for today. And as we get into as we start to approach T-0, everyone here is clearly very excited for the events that are happening today. So as we get closer to T-0, I'm going to throw it back to Hawthorne to talk more about our rocket.
Awesome. Thanks so much, Zach. And we've actually got a little bit of a crowd forming behind us, too. Now, we've got a shot of Starship on the screen. The entire Starship structure you see is made of stainless steel. And when that's fully stacked, it stands about 120 meters tall and about 9 meters around. To help you give a sense of just how big that is, we've captured a video of some of our teams doing final integration prep work in advance of today's test flight.
Just like Falcon 9, Starship has 2 stages, which we will talk a little bit more about in a minute. But in addition to those 2 stages, Starship actually has a 3rd stage called Stage 0. It consists of all the launch pad infrastructure built around the rocket. You can see a great view of it there on your screen. It's truly an engineering feat in its own right.
And I feel like it's something we don't talk about very often. There's a lot of infrastructure that goes into fueling and preparing the launch vehicle before a large test like this, really any launch. Now, let's talk about Super Heavy. The name says it all. It's super, it's heavy, it's super heavy. It goes by some other names, the first stage or the booster, but whatever you call it, the Super Heavy will be the vehicle responsible for powering Starship against that mighty gravitational pull we've got here on Earth. And when it's fully operational, it's going to get Starship to orbit.
The booster alone stands about 70 meters tall and is about the same height as a fully integrated Falcon 9, but with a diameter roughly 2.5 times that of Falcon 9 and with 33 much larger engines.
Yeah, and having those engines, and oh my gosh, I love this shot. We can see looking up into the launch mount at the 33 engines on the booster. Those are each of the Raptor engines that's going to power today's launch attempt.
Yeah, this is an incredible view. One of my favorite views that we're going to get today. We don't have this kind of view on our Falcon 9 launches, so this is so exciting to see. You can even make out the paint markers indicating which engine is which. Like we said, there are 33 of them. So there's a lot of fire that's going to be coming out from those engines in just over 31 minutes from now. As we mentioned before, there are 33 of them on the Super Heavy, the booster, and we don't see it right now, but the cluster in the center are the ones that are actually going to gimbal and help steer the booster back down for its water landing in the Gulf.
Yeah, and they're a little bit different, Kate, than our Falcon engines. So on Falcon, we use a gas generator cycle. Here's a fantastic shot, actually, at the inner stage, so we can see the 6 engines that are on the ship side, 3 gimbaling in the middle, and then the vacuum engines, you can see 2 of them, and the other ones on the other side of the cluster in the middle here. So Raptor's a little bit different. It uses something called stage combustion, which means we basically pre-burn both the fuel side and the ox side, and then get those up to the right temperatures and pressures, and then mix them in the combustion chamber. It allows us to get higher thrust and higher efficiency on these engines than on Falcon 9. Now, Super Heavy also has 4 grid fins to assist with orienting itself during the return back to Earth. as today is the fully integrated flight test, and the first one, we're focusing on safely testing just the fundamental systems and operations on the vehicle. So what that means is we won't be attempting to land on land today. Instead, Super Heavy is going to be making that hard water landing in the Gulf.
Starship, or the spacecraft, is the second stage and makes up the top portion of the vehicle. It's designed for carrying passengers and cargo between destinations on Earth, Earth orbit, and planetary destinations. It stands 50 meters tall, a little taller than the Statue of Liberty. It's comprised of 6 Raptors. We saw those just moments ago. 3 of them are optimized for sea level, and the other 3 are vacuum engines, and they're optimized to operate in the vacuum of space. They provide a maximum of 258,000 tons of thrust in vacuum. The spacecraft is also outfitted with 4 flaps to help aerodynamically control the vehicle's attitude during atmospheric flight and enable precise landing at the intended location. You can see a view of those flaps there.
Now you can see the entire stack is vertical, and that's because Starship is designed for vertical takeoff and landing, as opposed to taking off and landing like an airplane. And that's really important because we don't have runways on the Moon and Mars. Fortunately, gravity at both of those destinations is not nearly as high as it is here on Earth. On Mars, it's about a third of what Earth's gravity is, and on the Moon, the gravity is just a sixth of what it is here. So Starship can take off in both of those cases without needing the Super Heavy booster like we need here on Earth. Now, for today's test, Starship does not have its landing legs attached, and that's because we aren't going to be attempting to return to the launch site or land on land. It's going to be doing another hard water landing at the end of today's test.
We can't wait. Starship is wrapped in a heat shield, which is composed of 18,000 hexagonal ceramic tiles designed to insulate the vehicle during atmospheric entry, where temperatures can be as high as 2,600 degrees Fahrenheit. The hex-shaped tiles, like these ones that we have here, roughly make up about 2/3 of the vehicle. There's a couple of different geometries. The one that I have is for the circular portions of the vehicle, so it has this curvature to it, and the one that Shiva has.
Yeah, this kind is a hexagonal shape, and there's several thousand of these all across the body of the vehicle. And it's worth saying we need these because when a spacecraft re-enters from orbital velocity, it's going faster than the speed of sound and causes a lot of heat to build up that has to get dissipated by these heat shield tiles.
Yeah, thing that's really cool about these is they're super lightweight. Even just holding them, we're able to even just hear how hollow they are because of the construction. But they do a great job of dispersing that heat during that atmospheric reentry. We actually produce these in-house at what we like to call the SpaceX bakeries. And they're located in Texas and Florida. So it's something that we designed and build in-house. And like we said, there's thousands of them. You can kind of see them on the exterior of the vehicle. So at this point in time, we are at T-minus 27 minutes and 18 seconds. So let's head on over to John Innsbrucker for an update on the countdown. Hey, John.
Thanks, Kate, and good morning. I'm John Innsbrucker, Principal Integration Engineer here at SpaceX. We're currently loading propellant from the ground system into both the first and second stages. Now, both vehicles use the same 2 propellants. Our fuel is liquid methane at a temperature of just over 100 kelvins, or about minus 272 degrees Fahrenheit. Now, this is a different fuel from Falcon 9, where we use RP1 kerosene. And our oxidizer is liquid oxygen, the same as Falcon 9. But because there's no oxygen in space to support combustion, we have to bring our own. Now, a little bit of a recap. We did the go, no go poll at T-minus 1 hour and 45 minutes. And once the team gave their goes, we polled about 20 folks. We started loading propellants onto the booster at T-minus 1 hour and 39 minutes. And at T-minus 1 hour and 22 minutes, we began propellant loading of the ship, the second stage on Starship. Now, LOX loading of the second stage main tank is almost complete right now, but we'll actually stretch it out and wrap it up and finish at T-minus 5 minutes. And then at T-minus 3 minutes, as the booster finishes loading, the vehicle will be fully loaded with just over 10 million pounds propellant. Now, currently in the countdown, we've just passed the T-minus 26 minute mark. The good news is weather's looking good. You can see the blue skies there on the camera views from the drone. The only thing we're watching is winds. They are within limits at ground level. We expect they may pick up a little bit as we get farther into the window should we need to go that far. But the good news right now is that the weather is looking good. The range also is looking pretty good. We've moved almost all the boats out of the keep out zone overnight. We are working one, but we're still underway. And right now, as a reminder, if for any reason we do not make our test flight today, we have backup launch windows. This could be either 24 or 48 hours after today, and it'll depend on how far we get into the countdown. But coming up on 25 minutes to go, everything is looking good, Kate.
In order to make life multiplanetary, we need a fully reusable vehicle that's capable of carrying a huge amount of cargo and a lot of people to orbit and have a pretty quick turnaround. The idea is to effectively reuse launch vehicles just like airplanes. Crowd is getting excited here in Hawthorne behind Mission Control, as you can hear. Now, imagine if you had to wait for a new airplane to be constructed every time you wanted to fly. You'd rarely go anywhere, and it would probably be completely unaffordable for most of us. In order for us to get to Mars and back with lots of people, multiple times, reusability is a must.
Now, in the near term and a bit closer to home here on Earth, Starship will be critical to other programs as well. Once it's operational, Starship will deliver the full-size and upgraded version of our Starlink satellites. And that's super exciting because our next generation satellites represent a step forward in Starlink's capabilities and will provide more bandwidth and increased reliability to connect millions of people around the world with high-speed internet.
And of course, Starship will fly a number of human spaceflight missions in the lead up to our first missions to Mars. Entrepreneur and pilot Jared Isaacman will command the first human spaceflight on Starship as part of the Polaris program. Jared served as a commander for Inspiration 4, the first all-civilian mission to orbit. Inspiration 4 launched aboard our Dragon spacecraft and Falcon 9 in September 2021, raising over $240 million for St. Jude Children's Research Hospital. The first human spaceflight on Starship will launch as part of the Polaris program, and you can learn more about that series of missions at polarisprogram.com.
Now, our first lunar mission around the moon aboard Starship will be led by Japanese entrepreneur Yusaku Maezawa, also known as MZ. MZ flew to space for the first time in December 2021, and he purchased all of the seats aboard Starship's first lunar mission in order to give artists and creators from all over the world the opportunity to go. And the hope is that what they will create in space will further inspire all of us here back on planet Earth. Now, over 1 million people applied for this mission, and earlier this year, they announced the final 8 crew members were selected, and you can learn more about them and MZ's mission at dearmoon.earth.
Dennis and Akiko Tito are the first 2 crew members announced to fly on Starship's second commercial spaceflight around the moon. This will be Dennis's second mission to space after becoming the first commercial astronaut to visit the International Space Station in 2001, and Akiko will be among the first women to fly around the moon on a Starship. The Titos joined the mission to contribute to SpaceX's long-term goal to advance human spaceflight and help make life multiplanetary.
SpaceX is also incredibly honored to be part of NASA's Artemis program to establish a sustainable presence on the moon to prepare for missions to Mars. Starship's early test launches, followed by those regular Starlink deployment missions and propellant transfer demonstrations, are directly advancing NASA's Artemis program, along with SpaceX's ongoing mission to make life multiplanetary.
SpaceX will conduct an uncrewed demonstration mission to the moon prior to the Artemis 3 mission, which will mark humanity's first return to the lunar surface in more than 50 years. It's an exciting future, but let's talk a little about how we got to today.
Now, Starship testing ramped up in July of 2019 with the Star Hopper prototype. It's sort of a short version of the Starship that we see today. There's a picture of it on your screen, the lovable water tower. Now, standing at just over 18 meters tall, the Star Hopper had a single engine and was test flown to perform landing and low-level altitude maneuvers. Starship's initial flight test was a hop that reached about 20 meters in altitude, This was followed by a second hop, the one that we've got on our screen, that rose to 150 meters in altitude. We took a little jaunt away from the launch pad and ended up landing about 100 meters or so further away from it, and you can see that on your screen. Now, notably, this was the first time that we had used a Raptor engine in flight and demonstrated control of this kind.
As a Star Wars fan, I can't not see a flying R2-D2 there. Now, after a series of 150-meter hop tests with earlier prototypes, the Starship program saw a huge breakthrough during a test flight of the vehicle known as serial number 8, or SN8. SN8 demonstrated a first-of-its-kind controlled aerodynamic descent and landing flip maneuver. Yes, I'm talking about the belly flop. This 12.5-kilometer hop test took place December 2020 and saw the SN8 prototype ascend to an altitude of 12.5 kilometers and conduct a belly flop maneuver. While it didn't stick the landing, the test was a major milestone in the development of Starship.
I love seeing the belly flop maneuver. Now, testing continued with the prototype on serial number 9. That was a 10-kilometer flight test in February of 2021. We had a nominal ascent, engine cutoff, reorientation, and controlled descent were stable. However, we unfortunately had a dramatic ending to the end of that flight when we had a failure on its engine to relight. That resulted in one of those rapid unscheduled disassemblies. But what was really, really exciting about both serial numbers 8 and 9 is how quickly we were able to achieve just our primary objectives in those 2 high-altitude test flights. In addition to getting lots of great data, Starship successfully demonstrated control of the vehicle and subsonic re-entry capability.
Ultimately, we performed 9 Starship high-altitude test flights in total, and in May of 2021, SN15 launched from Starbase, reached an altitude of about 10 kilometers, performed a number of maneuvers, and safely returned to the launch site. This was the first Starship prototype to fly, control its descent, safely land, and to be recovered in one piece.
Now, having achieved that success in our suborbital campaign, one of the next big challenges for upper stage reusability is to survive the high heating hypersonic phase of entry. Combined with the ability to refill our Starship's tank with fuel and oxygen while on orbit is what will enable a fully reusable transportation system that's designed to carry both crew and cargo on these long-duration interplanetary flights, and that's ultimately what will help humanity return to the moon and travel to Mars and beyond in our solar system.
So as you can tell, it is nothing but an iterative process to get to the point that we are today and where we will go from here. That iteration is a core process of how we work here at SpaceX. We like to fly and we like to test early and often, both on the side of hardware and software.
Yeah, that's an awesome point, Kate. Now, we are continuing our countdown to Starship liftoff just over 17 minutes from now. So, of course, let's check in with John for another status update. John?
Thanks, Shiva. Clock is coming up on T-minus 17 minutes from liftoff. We're continuing to click towards 0. However, right now, we've just begun listening in. The first stage team is working a pressurization issue. They're troubleshooting that right now. Now, we do have the option, if need be, if we can't solve this, then we would hold the count and probably treat today as a wet dress and not be able to launch. However, we are continuing to do propellant loading on both the Super Heavy and the ship stages. Now, most recently, we began loading liquid oxygen and methane fuel into the header tanks on Starship. At the very top, just underneath the nose there are 2 small spherical tanks. That's where the fuel and liquid oxygen header tanks are. That started at T-minus 27 minutes, and that propellant loading will continue until T-minus 9 minutes. We'll also continue loading the main tanks of the Starship second stage, although they're pretty much full right now. Everything will drain back as we get ready for launch at T-minus 5 minutes. Now, on the first stage, we're continuing to load the massive amount of propellant onto the Super Heavy booster. That's going to continue until T-minus 3 minutes. You can see the frost line on some of the views as both liquid methane and liquid oxygen go into the tank. It's 16 minutes and counting. We're also currently configuring the launch pad for liftoff. The booster hold downs are being prepared for the release at liftoff, and the second stage quick disconnect is beginning its configuration for release. The liquid oxygen and methane that are going into the second stage go through that quick disconnect. You can see it in some of the views, the arm that comes out just to the base of the second stage. That'll move out of the way as we lift off. At the same time, the SpaceX team continues to check in with the Coast Guard. We're working one boat that's in the safety perimeter. They are working to get that boat out of the way. We cleared several other boats out overnight. We're down to one, and we expect that'll be clear so that we can proceed with launch out over the Gulf of Mexico. But as a reminder, T-minus 15 minutes, 10 seconds and counting. We are working an issue on the first stage, and we'll bring an update as we get more insight into that issue.
Now, today's test flight is taking place out of our Starbase facility in South Texas, and that facility has gone through a tremendous amount of change and growth in a really short period of time.
Yeah, I mean, 3 years ago, not much even existed there. It was a very different scene, as you can see by that photo there on your screen. Fast forward to today, and the team is building out an entire production line.
Yeah, last year they built 4 Starship Super Heavy boosters, 5 Starships, our 200 Raptor 2 engine, and this year they're targeting 5 boosters, 8 Starships in production for 2023. And really, you do need a production system to rapidly iterate, like we were talking about earlier, on the design of the vehicle as we learn more about it from these large tests.
Yeah, absolutely. Pulling on my industrial engineering background, system fill is something that is critical to that goal. Being able to produce and launch multiple Starships means that we have to have a system full of those production vehicles, and we iterate on each one. So even the next Starship that will fly in whatever the next test is will be different than the one that you see there on your screen now.
Now, the employees who have been at SpaceX a while say that Starbase does remind them of the early Falcon 1 days, except moving a whole lot faster.
The team at Starbase is expanding as fast as the facilities are, and if you've ever wondered what life at Starbase is like, here's a quick peek. Starbase directly employs more than 1,800 employees and is actually the largest employer in the area.
Yeah, and from that video, you can really tell, like, it's a beautiful location. It's close to the ocean. There's tons of wildlife. And that's because being close to the equator is actually a fantastic way to get to orbit.
Yeah, I love that we have so many employee events that allow us to participate with ocean cleanup and other environmental efforts there. We'd also like to thank Cameron County for being so supportive for all of our work in that area. Now, in addition to Starbase, we'll soon be adding another Texas location to the SpaceX family. We're opening a new facility in Bastrop, Texas, just outside of Austin, to support Starlink hardware production. The new facility will be over 500,000 square feet of manufacturing space, and the team has already started hiring.
Now, we have all kinds of openings in production and manufacturing for technicians and leadership and manufacturing engineers and all kinds of site support roles. Basically, if you can think of a role, we're probably hiring for it.
So if you're interested in helping expand human life to other planets or helping internet access here on Earth, consider becoming part of the SpaceX team at spacex.com/careers. Now, with that, let's check back in with Zach down at Starbase one last time before launch. Howdy, Zach.
Hello, Kate and Shiva again. You can really feel the energy here at South Padre Island as more of the SpaceX team have gathered. We're standing just over 5 miles away from the launch mount, and so from here we've got a very nice view. I would basically say these are some of the best front row seats you could get, and might I add, beachside as well. Now, the Starship team has worked incredibly hard to get ready for this test, and we're all clearly excited for T0. And as we get into the final moments, one issue that could hold the countdown or cancel the test altogether is if a boat enters the safety perimeter. Now, over my shoulder is the Gulf of Mexico, which is normally very open to all of the boaters and fishers. However, today, SpaceX is closely coordinating with the United States Coast Guard to establish a safe zone and ensure public safety. And up to T0, SpaceX is in regular communication with the Coast Guard to ensure there are no boats in the area leading up to the launch. Now, fingers crossed that that does not happen. Now, I'll throw it back to the folks at Hawthorne as we get closer and closer to that T-0. To all of the boaters and fishers, however, today, SpaceX is closely coordinating with the United States Coast Guard to establish a safe zone and ensure public safety. And up to T0, SpaceX.
We're just inside T-9 minutes and counting. We're listening on one of the background loops right now. Flight director is talking about the issue we've had on first stage, working the pressurization system. Decision right now is that we are going to stop the launch for today. We're going to transition the launch attempt to a wet dress rehearsal. So that means we're going to continue with the countdown sequence of events. We'll continue loading propellant, finishing up here shortly on the second stage. We'll also continue loading propellant onto the first stage, wrapping up at T-3 minutes. We're also going to go through pressurization steps, other steps of the countdown. This will be a full validation for the team, but currently the plan right now is we're waiting for final word, is that I think at T-10 seconds, we will finally stop the clock and then recycle the countdown for today. Now we're inside T-8 minutes and counting. We're continuing to load propellant on both the first and second stage. You can see the Starship second stage with the heat shield tiles there. Carriage arms are open. You can see the condensation around the first stage tank as we load liquid methane, liquid oxygen into the large super heavy first stage. Now that propellant loading is continuing until T-3 minutes. As a reminder, and there's our great view looking up at the Raptor engines, the 33 engines. There's an outer ring of 20 engines, and then there's an inner set of 13. Those are the engines that can gimbal and adjust the course of the Starship vehicle on the way up. And of course, the first stage as it comes back down towards the water landing in the Gulf of Mexico. Now, when both stages are loaded, you can see the condensation frost on the side of the first stage. We'll have just over 10 million pounds of liquid propellant on board. Inside T-7 minutes, we're continuing to count. Team is preparing for the hold and scrub at T-10 seconds. Now, the good news is everything's been going good. We're just working that one issue. So we are continuing to count. Team will get this as an excellent opportunity to run the end-to-end of the system. Now, in a launch, in the next few minutes, the guidance system would be performing its final alignment. We will be doing that this morning. The automated flight termination system would be armed. We won't need to arm it today as we won't be flying. And we'll do final thrust vector control checkouts, what we call wiggles of the Raptor engines on the first and second stages. Now, normally in a countdown, if we needed to hold, there's a view of the second stage Raptor engines just above the first stage. Now, as I mentioned, in a regular countdown, if we needed to hold, that would come at T-40 seconds. That's the point in the countdown where we can pause to wait for final checkouts or pressurization to complete. Now, earlier this morning, we thought we might have to hold at 40 seconds. Everything's looking good, except for the one pressurization issue that the team is going to have to troubleshoot after this morning. So we won't stop at 40 seconds right now. We'll continue all the way down to 10 seconds, and then we'll go into a recycle.
Jumping into a wet dress rehearsal here, and I actually
now
think
we're coming up T-minus 5 minutes. Overall, though, Kate, Shiva, it's been a good day. It's a little sad listening to the flight director say that we're going to have to stop at 10 seconds, but I guess that's for everybody. It gives us a real run-through of the launch vehicle.
Yeah, it's unfortunate. Of course, we wanted to see fire today and lift off, but that's okay. The point of the countdown is to allow the teams to progress to that T0 time in a coordinated fashion and really to unveil any issues prior to the ignition sequence. So the countdown did its job today. It allowed us to identify that press issue, and like John mentioned, the teams are going to work through it, and we are going to basically call it off at T-minus 10 seconds. But the integrated launch teams and us, we are going to treat this as if it were still a launch day. We're going to do this, what we now call a wet dress rehearsal.
Yeah, and we've mentioned the term a couple of times here. We call it a wet dress rehearsal because we are wetting the propellant tanks. We are loading propellant into the vehicle. We've talked about the frost line a little bit here. That exercises the stage 0 system, the ground system, all of our infrastructure that loads propellants onto the pad. That exercises our procedures for the mission control teams. We're monitoring telemetry on the mission control consoles, looking at the pressures and the rates and the temperatures. And some of those things look a little bit different when you're getting up to the pre-flight pressurization levels and full propellant load. So we're learning things today about the integrated tests that are going to set us up for success in a future attempt later on, hopefully in the next 48 hours or so. And Kate, like it's also worth mentioning here, we're still going to take the count through to a pretty around the T-minus 10 second mark. So we're really going to exercise everything that we would up until that point in the vehicle states and ground procedures.
Yeah, it's like we said before, any data that we can collect today is super helpful. And that's exactly what we're doing. We are continuing to collect this data and allow the teams to have be better informed for the next attempt. Unfortunately, due to the needing to recycle the propellant, we are looking at a minimum of 48 hours until we are able to attempt this flight test again. So we're not quite sure what that timing will be at the moment, but we're looking at a minimum of 48 minutes. Or excuse me, of 48 hours at this point in time. But Shiva, exactly as you said, things look a little bit different on launch day. And we allowed the countdown to do its job, to basically get to this point, to allow the teams to work through the issues. And we're going to continue, like we said before, we're going to continue all this down all the way to T-minus 10 seconds. And that will really allow the teams to pretend like this is launch day and continue and gather that data.
Yeah, Kate, on the one hand, it's a little bittersweet. On the other hand, we watched them go all the way through. First stage propellant load, just now wrapping up. The second stage, even the header tanks up under the nose of the Starship that you can see on the monitors. Actually, that all went very well today. The weather was excellent. Everything was looking good. Sadly, we just have the one issue, but that is letting the team continue to count down. And we're going to continue with it here until we get the clock hold at T-minus 10 seconds.
Yeah, so for those of you that have just joined us, we're now at T-minus 1 minute and 30 seconds to what would have been the launch of our Starship flight test. But unfortunately, due to a stage 1 issue, we are going to utilize today as a wet dress rehearsal. Instead, we are not going to attempt launch. The teams are basically saying that we're scrubbing our launch attempt for today, and we are expecting a minimum of 48 hours in order to recycle. So it's all good news, though. There's nothing really to be sad about other than we had hoped to be able to lift off today, but that's okay.
Now, one thing to point out for folks, when we do come back, when we clear this and we fly, one of the things you'll hear in the last minute, you won't be hearing us because we'll be listening to the countdown. But at T-minus 30 seconds, that's when the flight director would give the final go for launch. Love to have heard that this morning, but it's something to look forward to.
Absolutely.
The other thing to look at is at T-minus 6 seconds, we begin lighting the engines. Up on your monitor, you can see there, T-minus 40 seconds. We did hit the 40-second hold point, and they are holding for a moment. In the end, they will release that hold. We'll go the last 30 seconds. But yes, when we do get to day of launch, the last thing to look at is in the last 6 seconds, light the Raptor engines in succession. So unlike Falcon 9, we're going to have to do that a little longer. We're hearing right now the clock is going to hold here at T-minus 40 seconds. The Super Heavy and Starship are looking good. So with that, Kate, it's been a fast-paced morning. We got through it fairly quickly. But at this point, we're going to have to call it a morning.
Yeah, that's right. So for those of you that have recently just joined us, we unfortunately had a hold on the countdown today, and that is going to scrub our launch attempt. But we are expecting a minimum of 48 hours in order to recycle. So be sure to keep an eye on our social channels, and we'll share information as soon as it becomes available. Until then, stay safe, and we'll see you soon.